here's Alex, and we are off to a Siebel 25 30-year anniversary celebratory installation video, where we do things a little bit different than in other installation videos, which you find in the description. The installation process for Siebel CRM is well known, and what you see in the background here might strike your curiosity with the fact that we are looking at Podman desktop and there's a terminal open for a container, and that container seems to be starting up as a Siebel server. So you can see the familiar site of Siebel processes, but it's certainly Linux and Podman desktop, and you see in the background there's a Windows desktop. So what I'm doing here is having installed Siebel CRM as containers within Podman, within the Windows subsystem for Linux on a Windows 22 server. So you see we are going to spice things up a little bit installation-wise. Now keep in mind, this installation is supposed to serve as a celebratory 30-year anniversary thing that is just here to show what Siebel can do and how you can operate Siebel in the modern day and age. But keep in mind that this is a sandbox environment, and everything you see here does not apply, I repeat, it does not apply to your project and your situation. So take everything with a grain of salt and buckle in for an hopefully educational ride. So in the course of this video and the following videos in this playlist, we are going to provision a Windows 22 server, which we already have, but we are going to provision the Windows subsystem for Linux version 2. And within that Linux version subsystem version 2, we are going to install Podman for Windows, and we are going to use the Oracle provided containers for Siebel CRM, so not the regular installers. We will use the container images to create a nice little sandbox Siebel Enterprise with a Siebel server, an AI, maybe a gateway cluster if we have time, yeah, because we can do it, and a database, of course. And well, that database will be running as a container too, which is an option, but it will be running inside Podman just for fun. And this will also allow us to use the Oracle provided sample database container to drop the sample database container, a container database, into that pluggable database here. So we will have the full Siebel Sample Database in a nice Siebel sandbox environment, still on Windows, so we can use any Windows-based browser or REST client to access Siebel. We can use, of course, and that's important for a sandbox environment for evaluation, you still want to be able to run Siebel tools or even the developer web client, which definitely is not available as a container because it's Windows. And we also will learn that containers need a persistence layer outside the container to, well, store information such as the database files or the zookeeper log files, etc. So there's a lot of stuff that should survive a reinstantiation or an update of the containers. So yeah, we will start with a blank Windows 22 server machine with a little bit of utilities already downloaded, but we will then proceed to, well, get the Windows Linux subsystem to run. We will install Podman, and we will get an Oracle database, empty still, but the future Siebel database, and we will establish the persistence layer for that database. So yeah, that's the next steps that you will see in the video. So here's my Windows 22 machine. I'm running this as a virtual machine instance on Oracle Cloud Infrastructure, but it could run anywhere on your laptop if it's beefy enough, in your data center, on-prem, or in any cloud you want. And just to confirm, yes, it's Windows Server 2022. It's a somewhat beefier machine than usual because I just want things to go really quickly. So when the Windows Subsystem for Linux, or WSL, came out in I think it was 2018 or 19, when in its version 1, which is obsolete now, so we use version 2. And that really caused a stir in the industry, because on a Windows platform you can natively run a Linux kernel, or well, Linux distributions, for example Ubuntu, and that really opens up a lot of doors, and we are going to use that. And on Windows 22 Server, according to the Microsoft documentation, it's fairly easy to install WSL by just doing, well, in bash it says here, which is funny because it's PowerShell still, and you do WSL -- install, and that sets you up your WSL. And well, that's interesting enough. So let's just see. We have previous versions. If you have older versions of Windows Server, you can follow that Microsoft documentation or other guides you can find on the internet. So let's get back to our blank Windows machine. Let's open PowerShell, maybe run as administrator for good measure. And we do WSL -- install. See what happens. Okay, it's installing a virtual machine platform, installing Windows Subsystem for Linux, downloading stuff. Okay, tells me that the system needs to be rebooted. All right, let's do that, and we'll come back right when the machine is back up. So I do a planned restart and see you on the other side. So the machine has rebooted, and I can see that after the reboot it comes up with a command line or box to download Ubuntu, which is the default distribution for WSL, as I learned on the Microsoft pages. And that's fine, because in the other system that I showed you already, I used no other distribution, so seems to do the trick for running the containers. That will take a while, so we come back once it's finished. So once the the setup is complete, you see a welcome to WSL screen, and well, Ubuntu is available. There's some settings there. Now it's just gone. Okay. And well, if we go back to our PowerShell, we should now be able to type WSL as a command to get into the shell. And that's the first time. It takes a little while, takes a little longer. And it creates a default Unix user account. That's my current user, OPC. So I acknowledge that by pressing enter. And I'm supposed to enter a password for that user, which is the Unix user. And confirm that. Okay, and you see that I'm actually on a shell in Unix. So yeah, everything is there, and it's mounted to the System32 folder. So if you have never seen that before, it's quite something, and it's available with Windows since roughly 2018, but the version 2 of WSL has changed things drastically. So this runs inside for, let's see, the geek. The geek inside me just wants to see how this looks on the process side. And there's quite a substantial process, VMMem, so virtual machine memory. So the entire subsystem runs on the Windows hypervisor as a virtual machine, which is automatically provisioned, so you don't have to worry about that. And so you can, of course, configure it, how much memory it uses, how much processors it can use. And for a Siebel environment, you need to beef that up. So we'll come to that later because, well, you need obviously all the processors and you want to use a lot of memory for your Siebel environment, even if it's just a sandbox. So let's exit this shell, type WSL version. Let's see what you get. And that's definitely version 2 of WSL, which, yeah, I wouldn't have expected otherwise on a modern Windows 2022 server. You get the latest version of WSL, so no need to update that. There are, however, ways to update your WSL. Well, let's go to the WSL settings right away. So in your start menu, you see you can run Ubuntu as a shell. WSL and WSL settings should take us to a screen where we can assign, and that's exactly what we're looking for, the processor count. So my current machine setup has 12 processors and that all of them are used. The memory size is by default 50% of your current RAM. So I can use 36 gigabytes. Swap size is okay. So networking, let's check. We have NAT, which is probably good. We have the firewall enabled, so we need to make sure. But localhost forwarding is okay, so we should still be able to use the hosts on the local machine, on the host machine if you want. So all these settings you might want to review in your case. There's optional features. Well, enable GUI applications is turned on. We don't need that for Siebel. Nested virtualization might help, but it doesn't really help if your machine is already a VM. That's at least my guess. And so on. And there's some developer stuff. Yeah, so if you are keen on controlling the WSL, you see the settings right here. So the next thing we need is Podman. That's, well, a tool for managing, it says OCI containers in Pod. Don't confuse that with Oracle Cloud Infrastructure. It's actually Open Container Initiative. So that's another OCI there. And we are on the GitHub main page for Podman. Let's go to releases. There's a latest release. We should be able to download that somewhere. Yeah, so if we scroll down, we see there's a Podman setup exe. There's for macOS. So, well, choose your correct version. I go with the setup executable for Windows, obviously. And let's run that, see what it gives. So we are running on Windows Linux Subsystem, WSL v2. And yeah, it tells us if it's not already installed, you will have to install the virtualization provider manually, but we have taken care of that. So pretty straightforward process. Podman is now installed. Okay, what do we do with Podman? We can go to PowerShell again. And now since Podman is installed, we should be able to use Podman. And yeah, we get the help page. So we can do a lot of things, but Podman requires at least one Podman machine to run. So a Podman machine, so there should be a machine command, yeah, manage a virtual machine. So Podman uses the term virtual machines as well. So it's to host containers or pods, you need a virtual machine, and inside that virtual machine, you can host your containers. So if I type Podman machine, I should get a listing of, well, the available commands for managing virtual machines. So I have to initialize one. That's the first thing I have to do. And you should not just type init because it will use default settings. So you can use a command like, this one, where you can control the number of CPUs that this VM will use. So imagine you want to set up 2 Podman VMs on a beefy host. You have them use half of the CPUs or what. I'm happy with 8 CPUs. I'm happy with 32 gig of RAM for my modest Siebel Evaluation Enterprise. You can manage the disk size. It can use 200 gig is probably okay for Siebel. And rootful is that it allows containers to run in, well, root mode, which is good to have in an evaluation environment, but maybe not recommended for production environments. You be the judge of that. So we initialize that machine, and it starts actually downloading in, well, a container image. We are living in that day and age. And it, well, extracts the container image. Let's see, and it imports the OS into WSL. WSL is of course set up, and so we have success on that. Configuring the system. Okay, the machine is initialized, so we can do a Podman list or machine list. Forgive me, I'm new to Podman, so yeah, there's a machine, has never been up, so it tells us we have to start that machine in order to use it. Well, so let's run that start command. Starting a default machine, so that machine name you can also choose, but I did not give it a name, so my machine name is just Podman machine default. Might be handy if you plan to run multiple Podman machines in your environment. You start thinking about names. So it tells us that the machine has been started successfully. So we're still on the command line. Gets a little bit dreary on the command line. We have Windows, so let's get a Podman desktop. So Podman desktop is, well, a podified solution to developer needs. It's a, well, open source user interface for Podman. You have seen it in previously to visualize your machines and your containers and even create Kubernetes clusters and stuff like that. So all we need is the download. So follow the installation links for Windows. Download the Windows installer. There we go. And we download that. Okie dokie. Let's run the installer. There we go. And it says, welcome to Podman Desktop. And it's already in setup mode, get the extensions. So it has an extension model. I just keep the defaults here. Maybe turn off the telemetry. Start onboarding. So just Docker Compose support. Let's just keep going through. Yeah, that's fine. I actually, yeah, skip that. Okay, sorry. I just skipped a few things, but I got a page. There's some settings there. Preferences, appearance. Let's adjust the zoom level a little bit. Bit quirky. So 1 for 20%. Okay. So that's better on video. And let's change it to dark mode. Okay, so what do we have here? We have the resources, and we see that it located a Podman machine which is running, and We can create new machines from here. We can set up kubectl kind, local Kubernetes cluster kind of thing. And not sure about that disk size usage because it's not a 1 terabyte disk that I have, but the memory, CPUs. And if we look down here, we have containers, and there are no containers. So it's just a fresh machine. So we have the container in the container management machine, the virtual machine to run containers in. Well, we have no containers. We have no pods. We have, well, no visible images here. We have no volumes. And, well, let's not care about the other stuff. So all we want to see here is containers. And coming back to our graphic, we now have Podman installed, and we want a, well, for now, in this video, we want to make sure we have a Oracle database waiting to be filled with sample data. And that database should run as a Podman container for good measure. So how to do that? And the easiest way, there are a lot of ways, easiest way is to use a official container from Oracle. So you go to container-registry.oracle.com, and on the welcome page you already see the most prominent containers, our database, Golden Gate, but also Linux, OCNE. So a lot of stuff there to explore. And in the database, we are looking not for the latest database, the 23AI, although that would be great fun to run Siebel on that, but it's not yet certified for Siebel. So we go with an Enterprise edition, and well, 21C is the latest here, I can see, but we will also find older versions, quite sure. We will find that. And well, as usual, you have to scroll down all the way to find the older images, which is 19.3 is just fine for Siebel 25. And so we can just have the Docker, well, Docker, we're not using Docker, but we have the pull command for Podman. And it's a good thing if you have never done that before, to sign in at least once to the container registry. So I will just do that now. Well, tell me session has expired, which is interesting. So now am I signed in? Yes or no? So say sign in. So now I'm signed in, and you have to sign in at least once. And make sure that you sign the license agreement for containers. So it's displayed on there if you haven't signed it. I have signed it already. So the thing is, log in once, sign the license agreement, check the box and click the button, and then you can log in remotely to the Oracle Container Registry, as we'll do in a moment, and we'll pull all the containers you want. So we are back in PowerShell. We do a podman login to container-registry.oracle.com. We'll prompt for username, so use your username for the container registry or your Oracle account. We'll prompt you for the password, of course. And well, if you didn't mistype your password and you have signed that license agreement after logging in once to the website, you get login succeeded. So now you can use the pull command. Okay, so that's the pull command for Oracle Database Enterprise 19.3. And well, it's pulling. That is a significant size of a container image, 3 point something gigabytes. So it will take a while. So we'll just pause the video recording here. We come back once that is finished. Maybe it's a good idea while the image is being pulled and extracted onto your local machine, to acquaint yourself with the documentation, how to use this image. Of course, you would expect to just run it, not with Docker, with Podman, but then you would end up with a default password and stuff like that, and you want to have more control what goes on. So this is all described here, and so it's all about port numbers, changing the passwords, custom configuration. So now we're talking environment variables that will be set up so you can control the memory, the all kinds of stuff. So that is all documented here. So take a moment to digest that information. We will use a slightly custom run command in a moment to bring that database up. Speaking of the database, it's still copying blobs. So see you on the other side. And just a few moments later, we have a image. And of course, you could have done all of this in the comfort of a graphical user interface. So here I'm back in Podman desktop, and I can see the image now being available. And it's a whopping 8 GB. Well, it's an enterprise database after all. And you see, you can also download images from tar archives, as we'll have to do with the Siebel images, and load them. You can import images, you can pull images, so you can build your own images from a container file, of course. So the pull command, has you, obviously, connect to registry first, so you can set up registries. I could have set up Oracle registry here if I wanted to, and use the graphical UI, but command line is just fine. So what we have now is a container image. And every container, especially an Oracle database, needs to have a persistence layer, a place where it can safely store and find again the database files that an Oracle database uses. And for that, since it's Windows, we're going to use Windows Explorer, and we're going to set up a folder, a directory right here on the machine. So let's call it Oracle _data. You can use whatever name you want to. That's going to be our persistence directory, the directory that the container at runtime will connect to and use it to store all the persisted data. So that's, of course, how the vendor, Oracle in that case, or the developer, has configured the container, how to use that persistence directory. And we will see that this persistence directory is very important, because imagine, removing the container, and you don't want to remove your Oracle database or your Siebel database. So that stays on that drive, on that directory, and you run a different way of container, different configuration, and it will just hook up on that folder and its content and find the database and run it. Otherwise, you would just lose everything every time you remove a container. So that's why persistence is important. It's important in many parts of your life, probably. Before it's time to finally run that database container, let's pay a visit to another GitHub repo, Oracle Siebel. The Oracle Siebel team, mentioned on Siebel Hub and in our videos quite often, has a configuring Siebel repository. We can literally download it if we want to. We can just keep it. I use this as a loose reference to configure my container, since the database container is part of the Building Siebel for Docker case study. It's just a case study, so it's not written in stone. You have to do it like that. But if you go down here for the MDE and manage and scripts and automate architecture, we'll find the launch Siebel start all command. Starts a container first Oracle 19, and then it starts an AI container and Cloud Gateway container. I don't want to spend too much time here, but this is the sequence that Oracle devised as being good to start a simple case study evaluation style container environment, including the database as container. So here's basically somebody has done it before, run a container database for Siebel. So it might be interesting to look up that launch command. So that's in the generic container start Oracle 19. Well, and this is what I've been looking for, a Docker run command. Of course, we'll not use Docker, but we have all the necessary bits and pieces here to run the container well, suitable for a Siebel, for future Siebel and sample database deployment. Notice that there's a password already set for the system user. There's a SID preset in the environment variables. The database will join a network, so we have to set up that first. So we get some good ideas what's necessary, not just to run any container, that would be just easy, but run it with specific input, such as the port mapping. Yeah, you get the idea. Of course, we don't use Docker, we use Podman. So what I did was copy that stuff, the run command, and create my own command to run my container. So this is the command that I created. So Podman run -t -it, and here's the network. So let's stop right here because it will join that network, that Podman network. So we have to create that Podman network. So how do you do that? Just one moment. So let's use the command line and type Podman network help. Maybe that helps. Yeah, we can do Podman network create. Let's just do a Podman network ls first, to a list. There's one default network of Podman. We could use that, but we want our own Siebel net as it. That's the name I chose, or my good friend Duncan chose when he wrote the case study on GitHub. So let's do Podman network create Siebel net, and well, we have a Siebel net network. So don't forget to do that if you want to use your machines inside one specific network, probably. And network alias refers to the name that other machines can use in that network. So I keep the Oracle style here, Oracle 19C. That's the first port mapping for Enterprise Manager. So basically port 5500 of the container will be mapped to 5500 on localhost, on your host. Same with the very important, obviously, 1521 port. And I looked up several switches to, well, hopefully increase the amount of CPUs that this container gets. So this is just a desperate attempt to squeeze a little bit more performance out. This is in the Podman documentation. And here's the name of the container, not unimportant. So that will be visible in the container listing. That's another host name. Then we have V, the volume mappings. So this path in the Linux image that the Oracle container is will be mapped to, sorry for that, to the folder we created on Windows. Notice that this is just plain Windows path names, and this is a Linux path name. So this is inside the container, and everything using that folder inside the container will actually be directed to actually be stored here physically. And then we have the environment variables. I increased or set the database memory, the usable memory space, for 12 gigabyte. I keep that Oracle password that from the case study. You can, of course, set your own password here. That will be the password for the system user. And the SID, I also follow Oracle's lead from the GitHub case study. So ORCL CDB, the container database. And that's, of course, a container database you'll get. It's a 19.3. And last but not least, that's the image we're going to use to run that container. It will pull that image if it's not present. So it will be just faster if I have pulled the image before. So let's copy that and see what gives when we run it. And I prefer command line still, so it's a substantial command. As you can see, it's not just Podman run this container, it's Podman run this container with a lot of information. And if you get back this, well, number kind of thing, or this string, you know it has worked. So you can do Podman PS. We'll see it's starting, obviously, so always a good sign. And we can, of course, go to the Podman desktop, and now there's a container, it's already running. And if we click on that and go to logs, we see that it's on the first run for Oracle database container. So the first run takes quite a while, about 15 minutes or so. And you see it's copying database files. It's basically creating the default database service and copies obviously files. So if you're curious, you could go to your volume folder and you see, oh, it's, yeah, things are happening here. So the container is running and it's using that volume to create files, obviously. So let's not mess with that too much and let it just do its thing until it's finished. So we will just keep the log open and come back when the database is up and running. All right, so after, well, what turned out to be a little bit more than 15 minutes, we have a database that is ready to use, as the log says here. So that's the log of the container, and we can get into a terminal or shell by just clicking terminal here, or you can do the traditional Podman exec and stuff like that, and there should be SQL plus. It's an Oracle database, right? And let's try to get into that database. So we're in, so it's running, it's responding, and we can do connect, and we can use system user, and that password is, of course, or should be, the password we passed in as an environment variable. Now that's one way to do it, because the machine or the container image is set up to acknowledge or honor this environment variable and set the passwords accordingly. There are other ways to set these passwords after that, but it's not important right now. So let's just paste that password and we are connected. At that point, there's not much to do. It's an empty database. It's a container database, so we can plug in a pluggable container database, which is exactly what we'll do later in this video series when we install or provision the Siebel Sample Database using containers. So that's something that you might just want to see and try yourself. Of course, this database is like any other Oracle database, ready to act as a Siebel database, and you know how to set it up. The usual style, you can install a Siebel database using the database configuration wizard and stuff like that. But as we said, as we agreed, or I had you agree at the beginning of this video, we are just spicing things up here. So just confirm our container is ready to use. It's running, it's exposing ports. So I've been using the shell internally. I could also use SQL Plus from the outside, hopefully, and we have to for Siebel tools. So let's worry about that later if that port is really visible on the outside, or those two ports visible on the outside. One last thing you might want to check and marvel at the modern engineering for, well, a Siebel boomer like me. It's just magic that this folder on the local machine, the Oracle data folder, is mapped as a volume to the container, and the container has made good use of it. So here's the Oracle CDB, the default database with all its, well, redo files and stuff. There's the PDB1, the default container. So that's the first service we set up. We're going to set up another one for the Siebel database. And there's also the dbconfig, which, if you look closely, has the, well, SQLnet Aura and listener Aura and other files. So you could, let's check out the listener. Why not? Let's just open this here. And that listener is configured to listen for connections from everywhere, which is probably the best thing to have for a starter database. So it's not restricted and listens to connections from everywhere. So yeah, a healthy Oracle database is what we have now, running on Podman, on Windows Subsystem for Linux version 2, on Windows 22 server, so containers within virtual machines within containers, and it uses the persistence layer correctly. So that's where we stand at the end of this first video. Make sure to watch the other videos. We'll set about to, well, get the Siebel Sample Database and the Siebel environment going. Thanks for watching this one. See you in the next one.